Hello guys, welcome to my live stream. I'll be writing a 2D platformer, starting from scratch. So here we go. I'm first going to make some boilerplate files, just an init.py, stuff like that. I like starting my work in main.py, which means you can run the module directly instead of having to run a file which imports the module. Let's move this all full. Going. Flip. Files around. Yep. I'll be using modern GL. It's a Python module which abstracts over opengl. Some documentation on that. Like that. Telling me microphone volume is low, so let's do that. Is this any better? Let's keep going in the meantime. Let's go into my history, so I'll just now hold up, stop you and turn you into a black screen so you're not all seeing my browser history. History, modern GL. There we go. It's a fairly unknown module, so there's a it's kind of hard to find sometimes. Let's see if I can find the GitHub. Right, here we go. There's the documentation. Yeah, sorry about the noise. I've got a lamp with a noisy inverter. There's not much I can do about it. Well, or I'll have to sit in the dark, and I'd rather not. Anyways, let's go over here to some examples, I guess. Now let's go to the guide, perhaps. Give me a moment to find my bearings here, because I think this stuff is all for a... Yeah, this is a standalone context, and I'd like to make a window. Anyways, let's look at this. This is their examples are a bit weird. They have a module which imports other modules to run the example, so it's a bit tricky to figure out what's actually happening. So this should somewhere open a window, I hope. Oh, this is the base stuff. I need a specific implementation, I think. Let's see, SDL2. There we go. Yeah, there we go. Well, let's import SDL2. Hold up, I'm still getting to grips with my streaming software, so sometimes I'm a bit distracted with that. Let's see, let's just copy some of this, and then let's see what it's doing. Yeah, GL version should be 3.3, I think. Core profile, yes, forward, I don't know what that means actually. Let's Google that real quick. Yes. Yes. Oh, okay. So that basically means it won't support any of the older features. So you're basically telling it, I'm writing a new program, no need to worry about old features. There's a double buffering. Yeah, I guess let's start with double buffering. Why not? Doesn't really matter. Let's ignore multi-sampling for now. Yeah, flags. Create a window. Class COBRA. Let's copy these two in there. Like I said, this is a lot of boilerplate code. It's not the most interesting stuff, but it'll have to happen sometime. Define some constants, so we can later check the width and the height of the window. And let's set the flags to 0 for now. Yep. And then we can finally create a context. There we go. And do we want vsync? Yes, we do want vsync, I think. Yep. And then create a context. GL version code. Yeah, here you go. This is in the base.py, I think. So let's see if we can find what they are doing there. Yeah, that's just okay. So 330. It's just a different way of specifying the OpenGL version. Yeah, go away. Right, so then we have a context and we can mostly ignore all that other stuff. Yeah, you know what? Let's see if we can actually get this to run in the first place. Oh, you'll want to see my terminal, I imagine. Let me just add a source for that. Hold up. Existing, and now create a new terminal. And let's hit that one. There we go, and then don't forget the overlay. Existing, that one. And move it like that. Yeah, I can't listen to how I sound on stream right now, because it will give feedback. Everyone will be listening to how I sound on stream. Right. Anyways, let's get to the right directory. Yep. And the chance that this will work is basically 0, but let's try it anyways. Oh, no module named modern GL. Whoops. Pip install GL. No, pip 3. Weird. Could have sworn I had that installed already. Of course. There we go. Now my limiter's not working. Oh, dang it, of course. Well, sorry about the background hiss, guys. I'm not really sure how to... actually, let's see if I can just move this one to 30. Close. Is this any better, like this? I've changed the gate volume, so it should at least stop hissing when I'm not talking. Where were we? Right, in the terminal, of course. So distribution found for SDL2. It exists. Let's see why that's not being. There's just a module called SDL2. Oh, PySDL2, of course. Gotta have the Py prefix, otherwise no one knows what language you're using. Wrong type. Well, that's not a very useful error, is it? L2 create window. Is that expecting a title, X and Y? Oh, it's probably the flags thing. There's some nonsense flag we can give it. There. Alright, we need at least this flag, I suppose. Let's, if that works. Now, argument 1. What's argument 1? Let's 0, 1. So it's. Why isn't that? Let's try -1, -1. Well, if anyone knows why that's not working. SDL window pass undefined should work. See if they have some tools. Now it should be a bit string, of course. Annoying. Wait, oh, I forgot to remove a self there. Wait, well, I had a flashing window there. You can't see it on stream, but you know, working, I guess. So let's keep going with that. We'll need an event loop. Keep the window open. Of course. A bit annoying to write this code because SDL2 is a very thin wrapper over some C code. So it's a bit tricky sometimes to figure out what kind of arguments it expects. Did not. Well. See while stop. Pull event. So basically what this function does is it'll return true if there's an event, and it will also stick that event into the event variable, which is a bit odd since you're passing it as an argument, but that's what C code does. And for instance, if the event type is quit, then we'll need to tell it to stop, and otherwise we won't. Alright, and then we'll want some cleanup code here, just so the window actually closes instead of staying open forever. Let's see. No, oh right, typos. Imports. Import C types. There we go. Of course, that's what you get for copy pasting code. Yeah, there we go. I've got a window. Let me add a source for that. No new game. Right. So, as you can see, there's a whole lot of garbage in the window because we're not actually drawing anything to it. So let's get back to the text editor and let's see if we can't get opengl to draw some stuff. Away. need to because it's a double buffered window at the end of a frame, you need to swap the buffers, otherwise it will keep showing the old one. Events, destroy. Is there anything actually in this example that does any drawing? The set viewport thing, or I mean in the SDL2 example. Oh, but it's the examples. Let's see if we can get this angle going. Yes, of course. Oh, there we go. The scene switcher stopped working. Let's clear it to all ones, which means white. And swap it, and this should actually... Yep, there we go. Oh, there we go. It's running a completely white window. Let's actually refactor this a bit to be a class, because we'll need that later on. Class renderer. So... yeah, this will probably need this as an argument. Maybe not. We'll see. Let's ignore that for now. Yep. Need that one later. Those two we'll need later. GTX will need later. Right, and then we're already... Oh, let's actually indent this correctly. So... make a... make a step function. Will be... This is the main loop. There we go. Let's see... self.window... Self.window. No, oh, of course. Tried running it, but it will only define a class. Let's actually move this to a new file as well. And just all of that in there. And from renderer. No, actually, just make an instance of that class and then run the main loop, and that should be it. Now, window is not defined, of course it isn't. Where did I forget one? Here. Onto the window. Yep. Yeah, forgot a self. And we're back at a fully white screen. Yeah, let's just draw something to see if it actually works at all. Actually, let's move this into the self.step function. Fix the indentation. Sure, this is set on the instance. So let's stop. So let's stop. That should still work. No, because event isn't defined. Right, of course. And then to double check a white window. Let's see what's next. Yes, let's just try and... I will need a shader program first, actually. So let's define a shader program here. So prog is ctx.program. Now this is all code I've written once or twice before, so I already know roughly how to do it. So I mean, I still need to look up a lot of stuff, look at examples, but at least I know the structure it'll have. Tell it again which opengl version we have. And then we define some properties this shader will take in and produce. Let's ignore color for now. Let's see. No, let's ignore color. So this is kind of like C code. It's opengl shader language. But it's very similar to C. So if you've ever written C code, this shouldn't be too unfamiliar. And basically what this shader will do is it will copy the vertices from the input to the output. So nothing too exciting. Actually this should be three-dimensional. Even though it's a 2D game, I'll want to later on make use of depth sorting. Or I guess C buffer testing. Depth sorting is a bit outdated. But the output here has to be 4-dimensional. There's a W coordinate, which is important for applying matrices. I'm not entirely sure of the math, but I know it doesn't work without it. Right, and then we need a fragment shader. A vertex shader operates on vertices, so the corner points of triangles. And fragment shaders work on pixels. So first the vertex shaders run and then the fragment shaders run. Again, define the version in, let's see, no, actually out 4-dimensional color, void main, and on fragment color, effect here, and let's make it black. There we go. That should render any triangle we pass it as a black triangle. Then, of course, we'll need something to render. So we'll start a array of vertices. We'll need numpy for that. Numpy as because you need to convert the list of vertices to a list of bytes, and numpy is quick at doing that. Actually, no. Is numpy.array. And then this basically is a list of vertices. Let's see, yeah, only vertices, which are 3-dimensional. So, like that is one vertice. And we'll need at least 3 to draw a triangle. Okay, let's see, -1, -1, +1. Then we need to make a vertex buffer object. Itself. And here you see how easy it is to convert these vertices to bytes with numpy. Otherwise, you'd have to loop you'd have to loop over all of them, and that won't be fast enough for a game. Then we need a what's it called? Vertex array object. Simple vertex array. I'm looking at an example in the browser, by the way. Don't think I'm typing all this from the top of my head. We'll tell it which shader program to use, which vertex buffer object, and what the attributes are, which in our case is only invert. There we go, and we'll want to remember that one for rendering. Then, should be as easy as that. That should render a triangle. Module name. Really? Odd. I think maybe Python 3 got uninstalled at some point, because these are all modules I've used before. Here. Just installing them. Exciting stuff. Nothing compared to an action movie. Way more exciting this. Right, I should probably tell you guys there's a website, glass.superdoxing.com. It's in the bottom of the stream as well, with links to, at the moment, to the Twitch and the YouTube channel. There's also a link to the design document which I made on Google Docs. The design document isn't finished yet. I'll work on it as the game progresses. And this is also where there'll be a link to the GitHub with the source code, in case you want to look at the source code at your own pace. Right, meanwhile this is done installing. Now that crashed. Now we forgot I'm not used to writing languages other than Python, so of course I'm forgetting the semicolon. No, I forgot a brace. I need to slow down with the typing, I think. At least pay more attention. Well, of course, that's not called that. There we go. Right, and then there's a big triangle in the window. So, woo, that's the basics of it. Let's see what would be a good next step. We'll probably need to let this rest for a bit, and we'll have to move on to the entity component system. So let's create a new file. Yeah, so you have an entity class, and basically the way this works, instead of inheritance, all your entities are basically the same. They can contain various properties, but it's not a is-a relation like you have with class inheritance. It's a has-a relation. So for instance, if you make a player object, it isn't a positionable, but it has a position. And it's a subtle different way to think about it, but it does mean that you don't get into the diamond problem. Let me actually see if I can find the Wikipedia page for that, so you guys can read that at home. A common problem with inheritance. I'll put it in the description on YouTube. Just remember that. I'm defining a slots property, which in Python is a special property, which means the class is more efficient space-wise. So it doesn't take up quite as much space in memory, which is important for speed in games. But it does mean you have to define all possible variables beforehand. So one of those is ID. Let's see. And the reason for that is you want objects to be able to point to other objects, and a nice way of doing that is with IDs. Then of course in the init function you'll want to assign an ID automatically. Current ID t.current ID increased by 1. So every entity made now automatically gets an increased ID. We'll also need to store these objects somewhere, so let's make a world. Here we go, self entities by ID is that. We'll also want to store an entity type, probably. Yeah, let's just, if not type base. Basically any subclass of entity will have to define what type it is. Actually, maybe I'm thinking maybe should go by class name, so we don't need that. And then we don't need that either. We have to be able to add entities to the world. Entities ID entity is entity. Oh, there we go. So you can't have the same entity more than once in the dictionary because it will just override the old one. Cells entity. And removing is a bit special because a lot of the times when you delete an object, there's still a lot of stuff with pointers to it. So you don't want to just remove it in such a way that everything else crashes. But I think for now we'll just remove them anyways, and if it gives problems later, we'll change this function to instead replace an entity with a dead object. So it doesn't get updated, but it still exists. Let's see what else. Right, I'm not going to define component classes, which is what you normally do for an entity component system. Since for a game you can usually just define all the possible properties and it's not too much trouble. So we'll probably need a position. Velocity is probably a good one. Yeah, we'll want a vector class as well to store positions and such and have useful functions to operate on them. I'll also define some slots there because it'll only ever be X and Y, nothing more. Define a basic init. There we go. And I'll have to define them here. And a velocity. Actually, you know what? Let's default velocity to just a 0 factor. 0 by 0. Let's see what else. So basically anything in the game world is going to inherit directly from entity and not from other things. Let's see. Yeah, that seems about right. By type, because we'll want to look them up by type as well. Type. Class. Name. Yes. Now actually these will need to be lists, of course. Or sets, I guess. Not in self-entity type. Now I'm doing this wrong. What's going wrong here? Why is this? I'll need to define components, not types. So components is going to be just a simple list, I suppose. Right, I'm doing this entirely wrong. Dang it. Let's try that again. So a component is basically just a simple holder for variables. Yeah. No. Init. So when you create a component, you want to define the slots as usual and then automatically assign stuff to it in enumerate args. If and then yeah, self dot. I'm basically just writing a function so you can pass any of these slots items as arguments, so we don't have to define that init function over and over again. Let's see. Slots. That's the key, and then the value is that. For key value in parse slot items. not in what do you get for that? Let's just make a value error out of that. It should basically never happen in actually running the game anyways. Nope. Just mainly so if I make a mistake in programming it, so I know I've made a typo. Dot format key. Otherwise it'll just set that on ourselves. Right. Should work. So for instance, something can have a position. Right, and we only need to define plots. Now maybe later it would be nice to have some kind of type annotation for this. Just so you can't pass in a number where it expects a vector. I'll also put velocity on there. Just because basically everything that has a position will want to move at some point. And then we'll have a drawable, which will contain sprite. Let's see, let's actually not capitalize these. Sprite of position velocity. Sprite needs a sprite index, a animation speed. Let's see, x divisions and y divisions. So basically this drawable will contain a sprite, but that may be a sprite strip that's animated. So it will need to know how many sprites there are horizontally, vertically, which sprite it's rendering, and if the sprite needs to automatically change to the next one over. So for instance, what we can now do, see, this isn't dependent on anything, so let's just write some example code. For instance, the player that might be just an entity. Alright, of course we forgot components here. Update this one. Set components. There we go. Might just be an entity with a position component, where the position is a vector. Let's say 32 by 32 pixels, and the velocity, actually let's make a default for velocity. No, let's not, it's all work. Now let's start it off at no speed. Let's actually make position a sort of physics entity, because that works better if we want to later incorporate collisions and such. So a player has physics, it also has a drawable, well, later on we'll be loading sprites and such. But since I don't have that yet, we'll just have to do it like this. There we go. So we might define a player like this. And then world can add player. And then the idea here is later on we'll be able to query the world on specific types of entities. So for example, we'll want to do stuff like get by components, and then tell it we want every entity that has physics and a drawable. This is convenient because, for example, the physics system can just ask for all the objects that need physics and ignore everything else. The render system, for instance, can just ask for all the drawables. Let's see what's next. We probably want to load textures next, so we can actually get a sprite in here somewhere. Let's actually, yeah, let's do that. Get by component. Let's just implement a slow version, a bit of a daft version of this function. We'll optimize it later. Quicker. Let's see. For entity in entities by ID.values. Components. We want to make sure that this is a set, so we can check if entity.components and components yield entity. So basically what this does is it compares two sets, returns the set of items they have in common. Actually, am I doing this even right? No, I'm doing this wrong. Need to do not. I think this is the one. So basically, if there's a function for this one, Python sets. Let me look that up. There's a function for that. 3.6 documentation. Go. Yeah, you can test whether one is a superset of the other. So we'll want to know if that is a superset of components. So basically, any entity that has all the components in this list will be yielded. So let's actually add some fake entities to the world and see if that works at all. So for example, a background might only have drawable and not a position. So let's try that. Add it to the world. And then print some debug stuff just to check to make sure that this works. Yeah, let's just get by component. So for example, if we want all the drawables, we can just tell it, no, actually, I did this wrong again. Entity.components. Let's make that a property. Actually, do I want to make that a property? Tricky. Yeah, we'll have to rewrite some of this later, but that's okay. You can just components is set x in components, and this can be a set comprehension instead. Let's see, e.class. Right, so now if we say we want all drawables, that should work, saving a typo here or there. I'll just run it directly this time. Now I'm already there. Python 3, easy. Physics takes no argument. Is that true? Alright, forgot to inherit. Component. There we go. Now, of course, that attr takes as first argument what object we want to set stuff on. The object has no available component. Yes, it does. Right there. Did I? Oh. Possibly. No, huh? Why isn't it? Oh, it's a because it has slots. The entity to have a slot for those, otherwise you can't set it. Now, of course, it returns a. I try running it, but it returns a generator. So let's make that into a list. There we go. Type object is not ignorable. Now, of course, it has to be actually, let's add variable arguments. There we go. Returns 2 entities, and we haven't focused with. Let's make sure entities give something reasonable back. Self. At Python 3.6. Let's look that up actually. Python. Where did this get produced? Oh, Python 3.6. Okay, so I can use those. Awesome. Actually, name, square brackets, and self components. Go over here. And then we can see it returns both our entities, because both of them have a drawable object. But if, for example, we're going to look for physics objects, physics, and it should only return 1. Right, so it only returns the player object. So later on this will be useful when we start defining systems, because each system can just easily grab the entities it needs. Right. I'm going to end this here probably. Next time we'll have a look at filtering components by position, because that's something that will need to happen a lot for collision detection. And we'll probably also look at getting something actually rendered to our screen, because it's a lot of things that do nothing right now. So thanks for watching, everybody. See you next time.